Hello everyone and welcome to my channel. In today's video, I'll show you all you need to understand the faceplates in WinCC Unified. In a typical plant setup, we often deal with multiple identical devices, such as motors, that need to be monitored and controlled. Let's say we have 4 identical motors, each requiring variables for speed and status. The most basic approach would be to create 2 variables per motor, one for speed and one for status, resulting in 8 variables in total. However, this becomes tedious and inefficient, especially as the number of motors increases. That's where user-defined data types, or UDTs, come into play. Instead of duplicating variables, we define a UDT that contains both the status and speed variables. Once the UDT is defined, we can create 4 instances of it, one for each motor directly in the PLC. This gives us a clean, scalable structure that keeps our project organized and easy to maintain. Next, we need to make these PLC variables available in the HMI. To do this, we drag and drop the relevant DB tags into the HMI tag table, which automatically creates the necessary HMI variables. A straightforward way to visualize the motors would be to create one HMI object per motor. Motor 1, motor 2, and so on. But if we're dealing with many motors, this approach quickly becomes inefficient and hard to manage. This is why faceplates exist in WinCC Unified. We now create a single reusable faceplate to represent a motor. Inside this faceplate, we'll include a graphical representation of the motor using an SVG. If you try to drag an SVG directly into the faceplate and it doesn't work, it's likely because the graphic hasn't been defined as an SVG type in the library. Once properly configured, the graphic can be dragged in and even animated. Now we will include a text list to indicate the status of the motor. For example, when the status tag is 0, it should display off, and when it's 1, it should display on. We will see how to configure the text list later, but first we need to configure the symbolic I/O field in the proper way to display the text list. As well, we will include a graphic list, where a different image is shown depending on the motor's status. If it is 0, we will display a powered off image, and if it is 1, running image. And finally, an I/O field to display the speed of the motor, connected to the speed tag. To allow the faceplate to receive tags from the project tags, we use the tag interface. Here, we define a tag that connects to the UDT tag. To be able to select the data type UDT motor, we need to create it as type in the project library, just dragging and drop it from the PLC to the library. Once the tag is created, we can link now our speed I/O field to the corresponding tag. Now, to allow the faceplate to receive properties from the project, we use the property interface. Here, we define a multilingual text field to pass text from the project. This will be used to pass the motor name, and we link it to the title text object. Now, let's go back to the text list. To be able to use text lists in faceplates, we need to define them as library type in the project, as shown in the video. Here we should create the entries for the different values. When it is created, we have to link it to the I/O field and indicate the tag that will control the text list. In this case, the status tag. Now, for the graphic list, we need to create it as a property in the property interface, as we will use the project graphic lists. Create a resource list property. In this way, you can use as well the text list, but I don't recommend it personally due to performance. Now, link it to the graphic list. This is the graphic list project that we will pass while instantiating the faceplate. As we have finished our faceplate, we can release it. After releasing the faceplate, we go to our HMI screen and instantiate it 3 times, once for each motor. For each instance, we bind it to the appropriate UDT tag. Instance 1, motor 1, instance 2, motor 2, instance 3, motor 3, with the corresponding motor names and graphic lists. Now, we simulate the PLC and the HMI. We connect to the PLC online and manually change the values of speed and status to see the behavior. As you can see, they are properly changing. However, during testing, we realized that our text list wasn't showing any text. That's because we had left the text field empty in the library definition. To fix it, we edit the text list in the faceplate library. Add the correct labels, off, on. Release the updated faceplate again. After this fix, everything works as expected, and we now have a clean, scalable, and professional way of visualizing multiple motors using UDTs and faceplates in WinCC Unified. And that is all. Remember, every great project starts with a good idea, motivation, continuous learning, and hard work. Keep pushing forward. To stay up to date and never miss a thing, subscribe and turn on notifications. See you in the next video.